Yes, sir. Done.
Done. So this is the arrangement. So again see we have a round bottom flask. The round bottom flask with the reactant ammonium chloride and calcium hydroxide. But on the top again we are taking calcium hydroxide. I will tell you what is the reason why we are taking this excess calcium hydroxide. So then it is connected to a container which has a drying agent which is calcium oxide, and then it is connected to a gas jar. So when you heat this mixture of these two, ammonia gas is produced. Okay, so ammonia gas will be going through this delivery tube and finally reaches this calcium oxide. Okay, so this calcium oxide acts as a drying agent. Drying agent. So why drying agent? So when you heat this in the reaction, that is ammonium chloride plus calcium hydroxide, what does it form? It forms ammonia gas, calcium chloride and water. So you are getting water also as a byproduct. Calcium chloride anyhow it is a solid that remains in the round flask only. But along with ammonia what may come? This water vapor also comes along with ammonia gas. Okay, so that's why what do we do? To remove that moisture, you will use a drying agent. What is the drying agent here? Quicklime. Calcium oxide is the drying agent. So once the ammonia gas passes through this calcium oxide, what happens? It absorbs moisture and let the dry ammonia go. Okay, it will let the dry ammonia go into the gas jar. Now, since ammonia is lighter than air, so it can easily move upwards. So ammonia gas moves upwards. At the same time, the ammonia gas here it is trying to occupy the space. So that will push the air downwards. So air will be pushed outwards.
Downward displacement of air.
Yes. So this is called downward displacement of air. But the gas is moving upwards. Remember that. Don't write downward displacement of gas. Gas is moving upwards for ammonia, and air is displaced downwards. Did you understand this?
Yes, sir. So we can say that ammonia is lighter than air.
Oh yes, this is because ammonia is lighter than air. That's why we have kept the gas jar over there. Okay, right. So now we use this method, downward displacement of air, to collect the ammonia gas, but we have another method called downward displacement of water. Means you have to send the gas through water. So this ammonia gas cannot be collected by that method. Okay, we cannot use water here. Why can't we use water here to collect ammonia gas? Yes?
So it is highly reactive.
Not highly reactive. Ammonia gas is highly soluble in water. Because ammonia is highly soluble in water, you will not get ammonia back. It will dissolve in the water. That's it. It goes into the water. So that's why we cannot use downward displacement of water, or we cannot collect ammonia gas over water. Okay. Anyhow, I will give the precautions one by one. Okay. Did you copy this diagram now?
Yes, sir.
Okay. Right. First one. Precautions. We start with precautions. Precaution 1. What is precaution 1? First, calcium hydroxide is taken in excess. Okay, CaOH twice taken in excess. Why do we need to take? calcium hydroxide in excess. So we have taken a mixture of these two, and on the top again we are taking calcium hydroxide. Reason. The reason is here you are using ammonium chloride. This ammonium chloride is sublimable. This ammonium chloride is sublimable, means if you heat, what happens? It undergoes vaporization, turns into vapor directly. So the reaction will not happen. So before the reaction takes place, the ammonium chloride will vaporize. So you will not get ammonia. So that's why what do we do? To counter that or to stop sublimation of ammonium chloride, we put excess calcium hydroxide on the top. Okay, so that is the reason. Reason, what is the reason? To stop or to counter. Okay, to stop sublimation. To stop sublimation of ammonium chloride. Did you understand this? Why we are using excess calcium hydroxide?
Yes, sir.
Okay, and second precaution. Number 2. The round bottom flask which we have taken here, it is slightly tilted. Okay, it is not upright. Round bottom flask is tilted aside. Okay, slightly tilted sideways. What is the reason for that? Why it is tilted sideways? Let us take the round bottom flask upright. In case if you are taking the round bottom flask upright, what may happen here is you are heating it from the bottom, no? When you are heating it from the bottom, ammonia gas and water vapor both are there. So when water vapor tries to move upwards, what happens? By the time it reaches the top of the
Condensation occurs.
yes, at the top of the round bottom flask, what happens? Condensation of water vapor occurs. So because of the condensation, the water droplets will form and it will form streams. And the water stream will come down, and if the water stream touches the hot part of the round bottom flask, which is made up of glass, what happens? It will break. Okay? So when you put water on hot objects, mainly glass apparatus, when you put water, what happens? Because of the sudden contraction, the glass apparatus will break. Yes or no?
Yes, sir.
Yes? Understood or no?
Understood.
Understood. Okay? So that's what do we do? We put the round flask tilted, let the water vapor go immediately. Okay? So water vapor may be condensed here also. So if the water vapor condenses here, no problem with the process. Okay? So reason. What is the reason? So we don't write the whole explanation. Simply we write to prevent the water trickle down the round bottom flask and damage the apparatus. Apparatus nothing but round bottom flask. Okay, so just protect round bottom flask from the water. Round bottom flask. Yes, understood this procedure.
Yes, sir.
Yes, sir.
So now the purpose of calcium oxide. What is the purpose of calcium oxide? Calcium oxide acts as drying agent. Okay. Now, can we use other drying agents like concentrated sulfuric acid? Concentrated sulfuric acid is also a drying agent. Now, can we use this? Yes? Can we use sulfuric acid as a drying agent in this case? Sulf.
No, sir. They
No.
are reactive with ammonia.
Yes, very good. Sulfuric acid is not used as a drying agent here in this case. What is the reason? The reason is ammonia reacts with sulfuric acid. Ammonia reacts with sulfuric acid means you will not collect ammonia gas. If it reacts with sulfuric acid, you are losing it. You are losing ammonia gas. So you cannot collect ammonia gas. Right? So drying agent must be a chemical compound or a substance which only absorbs moisture and it does not react with the gas. The purpose of drying agent is to absorb moisture. That's it. It has to absorb moisture. It should not react with the gas. Yes, did you understand that?
Yes, sir.
Yes, sir.
Oh. And the method of collection of gas is downward displacement of air. What is the reason why downward displacement of air? Because ammonia gas,
Lighter than air.
yes, it is lighter than air. Okay? And so you prepared ammonia gas. Then how do we test ammonia gas? How do we test?
So you dip the rod in HCl and then try fumes will come.
Yes, we take a glass rod, okay, dipped in ammonia solution. Sorry, concentrated HCl, right? So this is a glass rod dipped in concentrated HCl. So when you keep it this near the ammonia gas, you will see the dense white fumes. Okay, so that is the test for ammonia gas. We can say identification test or we can use it as a chemical test for ammonia gas. Yes? So observation will be dense white fumes. Right? Understood? Any doubt?
No, sir.
Okay.
No, sir.
Right. So for today we stop the class here and we will continue in the next class. Okay. Tomorrow also we will take class. Okay. Are you busy tomorrow or available?
So you can take a class.
Okay. I will send a message about the timings.
Okay, sir.
Okay. Okay.
What do we mean conjugate